Okay. Eyes on the board, please. Does this look familiar to you? When you took your OPA test, you were given this exact same sheet. This is the formula sheet that you get for your MCAs for 6th grade. And if you notice, there isn't as much information as I would like to see on this. In fact, they tell you that area is equal to base times height. They don't tell you area for what. You have to know yourself that this area is equal to base times height is for any parallelogram. Okay? Now we have to make sure we understand what is a parallelogram. Here are all the quadrilaterals, four-sided shapes that fit under the parallelogram, because a true parallelogram has two different sets of parallel sides. Okay? So we could say a square is a parallelogram because it has two different sets of parallel sides. Now it has a few other things that it has to have. It has to have four right angles, has to have four congruent sides, but it definitely fits under the category of having two different sets of parallel sides. A rectangle, also known as a parallelogram, because it fits underneath that category, has two different sets of parallel sides, and it also has four right angles. A rhombus is also a parallelogram because it has two sets of parallel sides. Now a rhombus has four congruent sides, but it also must have two sets of parallel sides. So this works for all of those shapes. Base times height. And we're going to talk exactly about what it means for base times height. Because on a parallelogram, and especially a rhombus, we have to know what the actual height is. Because they could put in some dimensions that could mess you up. The only way to get to the height is to measure from the base, going straight up to the highest point, and it has to create a right angle from the base. That's the only way you get the height. Because this right here is not the height. We have to see, it has to form a right angle from the base. Okay, so we're going to talk about that. Anybody know what this formula is? Area is 1/2 of the base times height. Anybody know what that one is? Yeah.
Area for a triangle.
That's right. This is area for a triangle because we know triangles are half the size of parallelograms. Okay? And some of you may have memorized it as base times height divided by 2.
Yeah.
Who can explain why is 1/2 of the base times height the same thing as base times height divided by 2? Why is 1/2 of base times height equivalent to base times height divided by 2? I should see more hands in the air. Why are those two the same? Why are those two? Oh, we're starting to get a little more activity. Why are those two the same? Why does this equal this? We know that 1/2 of 4 is 2. 4 divided by 2 is 2. We know that 1/2 of 100 is 50. 100 divided by 2 is 50. Why is that true?
Because BH divided by 2 is half of base times height. That's what's over.
I would agree with you, but why? I'll give you a hint. It has something to do with flipping pancakes.
Oh.
Because division is the same thing as multiplying by the reciprocal. Okay? We've talked about that already, and that's something that we have to have down before we get to our MCAs. We have to know that if we take a number and divide it by 4, it is the same thing as multiplying by 1/4. We have to know that. That division is the same thing as multiplying by the reciprocal. Even if you don't use flipping pancakes for dividing fractions, some people find common denominators, we still need to know that piece. And that's going to be a concept that's going to be built on for the next couple of years in math, especially when we get into algebra. Okay? So there we go, an area of a triangle. This one right here we're going to talk about today too. This is actually area of a trapezoid. And a trapezoid has two sets of parallel sides. That's it. So we have two different kinds of really parallelograms. We have ones that start off looking like a rectangle or square. And then you can see that this side is parallel to this side right here. Okay. And then we also have another parallelogram called an isosceles, or sorry, trapezoid, an isosceles trapezoid. And that's where the two sides are the exact same. So this side is the same length as this side, and it looks here. And this is parallel to that right there. So this is the formula for finding area of those shapes. I'm going to show you another method that you can do. In fact, we can take a combination of these two right here to find the area of a trapezoid. Because I can break this into a rectangle and a triangle. And I can turn this into a rectangle and two triangles. Okay? Yes, ma'am?
For the parallelogram, well, that one, the weird-shaped one,
Mm-hmm.
but that one doesn't have any right angles.
No, but you see a line, a dotted line that goes from the base to the top, and I'll show you. There's a dotted line that goes from the base to the height that has the right angle symbol. Okay? Right here, this is volume. We're eventually going to get to volume. We'll eventually get to surface area and volume. In fact, that's the first thing that's listed on your tracking sheet. I believe that's for the benchmark 6311 is surface area and volume. And then we should all know Eric Eddy's rule. That's this one right here, where n minus 2 gives us the number of triangles that we can form inside a shape, and we multiply that by 180, and that will give us the sum of all the interior angles. Okay? So we need to know this. We need to be able to go down and identify what these actual formulas are. So some of you might, right when you get your formula sheet, might say, parallelogram. This is a triangle. This is a trapezoid. Okay? I don't know, maybe you could put, this is Eric's rule. Oh, A. There we go. Okay, area, many of you were able to find the area of this one. Remember, when we're finding area, we're trying to find square units inside. If we're trying to find perimeter, we'd be adding up the outside. We're going to try and find square units. How many square feet is this shape? And can we name, what type of shape is this?
Square.
No, it's not. I know it's not a square. Why is it a rectangle?
Because it has two sets of parallel lines.
Two sets of parallel sides. Okay, it is a parallelogram as well, by the way. Okay, but to be a square, we'd have to have four congruent sides. We don't have four congruent sides. Okay, what's that?
Mr. Zolkowitz keeps saying that it's not a parallelogram.
It is a parallelogram because a parallelogram has two sets of parallel sides. Now, there's many different types of parallelograms. This is just one of them. Okay, but the more specific name is a rectangle. Who knows the area for this? Go ahead. What's that? I'll give you a hint. Area is equal to base times height. What does the what does base equal? What is the base? Base is 10. What is the height? So there we go. Now, we need to be a little more specific. It's not just 80. It's 80 what? Feet squared. Now, here's why it's feet squared. It's 10 feet times 8 feet. And what is feet times feet? Feet squared. Repeated multiplication gives us those exponents. That's why we have feet squared. And that's why when we do perimeter, we would just label the answer as feet because we're not multiplying anything. We're just adding. Can you sit up straight, please? Thank you. Any questions on that one? All right. Here's our next one. Now, if the original one looked like this that you just saw, and we said that that full thing was 80 square feet. Now we're using meters instead of feet. I changed it. Okay. What would this triangle have to be? If this whole thing is 80, what does this triangle have to be? What's that? 40 meters squared. It's exactly half of. Okay. Now, we have to keep in mind that multiplication is commutative. I can take 1/2 of 8. What's 1/2 of 8?
4.
And take 4 and multiply that by 10. So 4 times 10 is 40. Or I could take 1/2 of 10, because it doesn't matter the order. What's 1/2 of 10?
5.
And 5 times 8 is
40.
40. Or I could do 8 times 10 first. 8 times 10 is,
80.
and what's 1/2 of 80?
42.
There's more proof that the commutative rule of multiplication is true. Doesn't matter which order we multiply numbers. Okay? Now we're getting to our parallelogram. Here's what you have to see, and usually it's not a solid line. Usually what you'll see is a dotted line here. And then you should see this right angle symbol. Okay? This right here, if they give you this distance from right here to right here, that is not the height. The height has to go from the base straight up to the top, forming a right angle. Does that make sense to everybody? So what would be the area of this parallelogram? Yeah. 96 centimeters squared. You did the base. Base is equal to 12. The height is equal to 8. And 8 times 10 is 80. And then we add 8 times 2, 16. We should get a grand total of 96 centimeters squared. Now we can say 96 square centimeters. It means the same thing. Okay? And the reason why we're squared is because we have centimeters times centimeters. All right? Now we get into this lovely one. Okay? And look at, I put areas equal to, uh-oh.
I know what it is.
Now there's a couple of different ways that we can do this. When I look at this shape, I can see a square and 2 triangles.
I don't see a square.
You don't see a square? I see a square. I see a square that measures 6 by 6. Everybody see that? 6 by 6 is, so this square is 36 yards squared. Now, if this whole thing is 10, and this is square, a square of 6 by 6, what does this part have to be, and what does this part have to be? 2 and 2? 2 plus 6 plus 2 would equal 10, right? Okay. So how do we find the area of this triangle right here? Say it again. 2 times 6. Divided by 2, right? It's actually 1/2 of the base times height. So it's 1/2 of the base, which is 2, times the height, which is 6. So we can either do 1/2 of 2 is 1. 1 times 6 is 6. 1/2 of 6 is 3. 3 times 2 is 6, or half of 12, 6. Okay? And this one right here would then have to be 6 yards squared. There's another way to do this. And this goes back to this first form. This is this formula right here. We take 1/2 of the height, and then we multiply that by the total quantity of base 1 and base 2. All right? So it doesn't matter which one we call base 1 or base 2. I usually call the one on the bottom base 1. Okay? So the full length of base 1 is what? 10. And then base 2, the total length of that is 6. What's the height of this? So the formula is this. 1/2 of the height times base 1 plus base 2. So let's pull out our notebooks and do that. Let's try and solve that, please. Okay? If base 1 is 10, put it in there. If base 2 is 6, put it in there. See if you get the same answer that I did. 36 plus 6 plus 6, 36 plus 12. See if you get 48. Okay? See if you get 48. Let's plug in the numbers. 1/2 of the height is what, class?
6.
The height is 6. And then we're going to multiply that by base 1. What's base 1?
10 plus 8.
Plus base 2. All right, now we have to do what's inside the parentheses first. What's 10 plus 6?
10 plus 6 is 16.
So we have 1/2 times 6 times 16. Now, because it's all multiplication, we can multiply in any order. And what I would do, instead of combining 6 and 16, let's make the number smaller. Let's take half of the biggest number. What's half of 16? 8. So it essentially is 6 times 8, which is 48, and we get the exact same thing as we got before. Okay? So you can either break this into smaller parts, or you can use this formula. Either one. And keep in mind, it will give you the formula for area of a trapezoid, but you just need to know what it is. Yes? You got a different way? What is your different way? You said 6 times 6? And 6 times 10? One of the 2's on the bottom? We'll have to talk after we get done here. I need to see what you're doing there. Let's have everybody pull out their planners, please. Planners, please.